As Renan said, my name is Jeff Bonkoski. I'm the Western Area Manager for Hazard Control Technologies. I started out as a career firefighter, retiring back in 2011 from Trenton, Michigan Fire Department, where I retired as a captain. I was trained to the level of a hazmat specialist in the state of Michigan. And after retiring, decided to start doing some consulting work and started with ethanol industry, which led me to trying to find a solution for some of the high hazard and difficult fires that firefighters are faced with. And I found the encapsulator agent F500 that we're going to be talking about and things that we have learned. So a little of my background. When I came and I found the encapsulator agent that we're going to talk about with Hazard Control Technologies, as you can see here, our goal is to make firefighting safer. And I hope that by educating and doing this presentation, I can give people a better understanding of what an encapsulator agent is and stop some confusion and some misconceptions of how we work and what we do. So to start that, our goal is to make the world a safer place through the fire prevention, protection, suppression. And the big thing is using a fluorine-free product. There's no PFOS, there's no PFOAs in the product. It's been tested. So this is a fluorine-free screen technology. And again, no environmental issues. We are a global company based out of Fayetteville, Georgia. We're not a startup. This is not a new product. It's been around since 1997. It just so happens that as it seems new, difficult fire situations evolve and this product gets tested, and we're finding out that we have great results in many different types of fire situations. And today we're going to be concentrating on the lithium-ion batteries and hopefully give you a better understanding of how the product works, because I know there's many people out there that truly don't understand, but yet they are out making comments. So I'm hoping to dispel some of those and get everybody a better understanding of this product. In the overview, like I say, we're going to be talking about the batteries and how they play, and we know they're in every part of our lives today, our cell phones, our laptops, our computers. You know, you could probably take a look around a room and you probably see multiple lithium-ion batteries, but they're growing not only in our electronics, but, you know, our children's toys and healthcare. Pretty much anything that's relying on some type of a battery source is switching over to the lithium-ion batteries because of the amount of energy that they can store. And it appears that these hazards are growing. And the batteries come in various sizes, you know, depending on what type of device they're being used in. The manufacturers can use different types of polymer pouch, the prismatic or the cylindrical style batteries. And, you know, they can make up these batteries and use them in the different types of devices that they need to be used in. As a real quick introduction,
shows what it looks like when a lithium-ion battery fails and sparks a fire, often because of faulty design or overcharging. Those batteries causing more than 200 fires in New York City alone last year, injuring 147 people and killing 6. And look at this battery catching fire and exploding next to a child.
Start of charge in 5, 4.
Our electric vehicles.
So this was part of a presentation that was just done by NBC, and it's rather long, so I'm going to speed up to it because, like I say, it covers some of the things that are occurring. You know, every day we're hearing about some of these fires and some of these instances that are occurring, not only in New York, but around the world. But one of the things that I wanted to point out is this also covers some firefighters that were injured.
They're also used in energy storage systems to store solar energy. Hunter Clare and Justin Lopez experienced the force of a lithium-ion battery fire firsthand in 2019.
Originally, we thought it was a transformer fire.
The Peoria, Arizona fire captains responded to a call at a facility containing thousands of lithium-ion batteries used to store energy for the power grid. You needed to make sure it was safe for the workers to go back into this building.
Exactly, so they could fix whatever the ultimate problem was. And as we went to leave at that point in time, it ignited, right? It blew up. I don't remember the explosion, don't remember anything from there.
The force blew both men under a chain link fence. Lopez landed 30 feet away, Claire 70 feet.
Where's he at?
The men nearly died.
I wanted to show that because it's going to be a something that I feel is very important, because when we sit there and we look at this event that occurred, the immediate thing was, yes, we need to address these battery energy storage systems, and we need to come up with a solution. And here our aim was to create the 855, the NFPA 855 committee, and put people together. But again, there's really been no testing to find something that's going to work to be able to deal with these types of emergencies. You know, we just put a group of people together and created a standard, and so on. And I'm going to be referring back to this as we continue on in the presentation. But the first thing I want to say and ask, as far as the question is, you know, is your team prepared? And I hope that as I go through this presentation and I give you a better background on Encapsulator Agent, how it works, by the end of this, your answer can be yes. So as we go through, what I want to do is, you know, how do most lithium-ion batteries start? And you hear it all the time. It's the trauma, the dropping, the overcharging, using non-OEM battery chargers or equipments or cables. So, you know, there's, you know, exposure to sunlight, you know, putting your cell phone up on a dash of the car and it overheating and so on. So we've been in and we've experienced all the different reasons why these batteries fail. And we understand, and we always hear that term, thermal runaway. And we know with the thermal runaway that it basically deals with one cell. And that one cell then overheats. It goes into thermal runaway. It affects the batteries next to it, which is now then referred to as thermal propagation, causing all the batteries within a module to basically fail and catch on fire. So it basically starts with one and continues on through the battery until they're all involved. The other things that we always hear about are the toxic off gases that are being released. You know, there's the CO, the CO2, the HF, the hydrogen, you know, many of these. And as we go through, we're going to see and we're going to talk about how the encapsulator agent is able to be utilized to help in mitigating some of these toxic and combustible or flammable instances. I want to show this. I'm going to mute it so I can talk, but this is a battery that would be in a vehicle that was tested. You can see how violent these batteries can, and I will say that this was extinguished using F500, and the manufacturer of this particular battery in use in vehicles is now an F500 user, but it just wanted to be able to show you how violently these batteries, and again, it's not just what you see with Teslas, but you know, it's all of these difference. And one of the things that everybody always talks about when they talk about the batteries, especially in many of the chat rooms, is that, you know, the F500 has to get at the batteries to be able to extinguish them. And I hope to give a little bit more of a response to that towards the end of the presentation. So just bear with me as we go through it. But the whole idea is to be able to deal with these batteries, being able to extinguish and being able to cool and stop the thermal runaway. And as we continue on, I hope to be able to show just how that works. When we sit there, we get into current events. I mean, again, they're so numerous, it's kind of hard to really list them all.
Oh, man, how to explain it?
People in East Harlem struggled to find the words, so stunned by the death of two people in an overnight fire. It broke out around 2:40 a.m. Wednesday. Residents tell us when they saw the broken windows, they instantly knew who was involved.
We both lived around here around the same time. You know what I'm saying, since we was little kids.
And had an awful feeling. What happened?
He was charging a bike.
Firefighters confirmed their suspicions with this tweet, saying that they determined that an e-bike battery was to blame. The tragedy now has a man in the hospital in a burn unit in critical condition, and it killed his girlfriend and his 5-year-old little girl. Neighbors say that happened.
So sadly, you know, and we keep hearing about these fires occurring, the impact it has on these apartment buildings and the deaths it's causing, not only here in the United States, but around the world. And again, looking for a solution. So when we get into this, and I can continue on in the presentation, I'm going to try to wrap this all up so you better understand again how these work. But when it comes to current events, we're hearing about these incidences occurring on a daily basis with these scooters and some of the other things. So the question then becomes, you know, when we look at how the lithium-ion battery, well, excuse me, the batteries or the current events, the foams, we have to look at what is the current suppression agent that your department or your people are using. And, you know, there's many people, when we sit there and we start looking at these agents, that are going to sit there and hear about an encapsulator agent, and they're going to confuse it with F500. We've got some that actually do form a shell, or they encase the battery. F500 encapsulator agent does not do that. And as I continue on, you'll see that. Some of the other problems when we sit there and we start looking at these agents and manufacturers of the batteries, some of the misconceptions is that while HCT has this third-party documentation and all this information on the ability of encapsulator agents to be able to extinguish the lithium-ion batteries, manufacturers are not necessarily endorsing the product because just that they don't want to specifically endorse a product. So our efforts are now to try to get them to endorse the NFPA category of agent that we fall under. And as I continue on, we're going to see that category of agent, the encapsulator agent. When we sit there and we start hearing about the testing that's been done, we're going to find out, and we're going to see how, when foam has been used to try to be able to extinguish these batteries, they don't work very well. Foams, and if we go to the NFPA 11 standard, we're going to see that foams are not suitable for three-dimensional fires. And what is a lithium-ion battery fire? It's a three-dimensional fire. Just like many of our flammable liquids or gases are. So right in the standard, if we look at NFPA 11, it's going to show how foam is not suitable for these types of fires. And we'll get into that a little bit more in some of the things that it's not suited for. One, it's not really rated for cooling the lithium-ion batteries. It does very little. I mean, at night, if you're cold, what do? You pull a blanket up. Well, what does foam create? It creates a blanket. So it's really not doing very much. And when it breaks down, we need to be there to reapply it and continually reapply it until we get down below that auto ignition temperature, or we get down below the temperature where that thermal runaway can reignite. Okay, so it really doesn't do much to help put these battery fires out in the difficult fires. So they are not very well suited for those types of batteries. When we look at the inerting gases, the two gentlemen that were in that video that talked about being blown through the cyclone fence. Okay, well, guess what? That system, that battery energy storage system, was protected by an inerting gas. Inerting gases are great for switch rooms. They're great for, you know, maybe data centers or things like that, where you might have some type of electronics that would be sensitive to getting wet, or your dry powders and things like that. So in those types of systems, inerting gases may work well. But when you start looking at a battery that can create its own atmospheres to burn, those energy storage systems, or those inerting gases, don't work very well in those energy storage systems, because when you open up the door, you still have that explosive atmosphere, maybe not the right oxygen concentration. You open up the door, now you're creating that explosive atmosphere. And as those firefighters found out, can be rather in some instances, and I'll mention as we go on, deadly when they do let go. Again, minimum cooling. They really don't do anything to stop the thermal runaway. while they may stop the visible flames, you still have the fuels and the oxygen. It just needs that air mixture to be just right, and we have that explosion. When we sit there and we look at water, which seems to be the agent of choice by many of the people that are out doing trainings and trying to explain how we should be dealing with these. Again, they're talking about copious amounts of water. And if we sit there and if we start looking at what a copious amount of water is, you'll sit there and in some of the reports, you'll see, it's 30,000 gallons of water for 1 Tesla, or it's 40,000 gallons of water, or, maybe 9 or 10,000, but the amounts are constantly changing based on the departments and how they're applying it and what they're trying to do. So we're finding out that water, again, is not a very suitable agent because it also it causes problems as far as reignition. We've got these stories and we have the reports of these batteries being extinguished with water, and it can be hours to days later that the batteries reignite. So water is truly not, the best because it's not stopping the thermal runaway. And we're going to get into the makeup of the battery and all of the hazards that are involved in the battery, and just again why the encapsulator agent is able to work so much better than these other agents that I've been talking about. The water again needed is the copious amounts. We hear about those reignitions. There's minimal toxic reduction, so that HF gas, and when the HF gas is hit with water, we're creating HF acid. So it's leading not only now then to not being able to reduce the gases, but we're creating another hazard with the water runoff. Where's that water runoff going, and what types of environmental issues or hazards is it causing? And again, you start hearing people talk about, well, so much water is used, it's really not. Well, that water's got to go someplace, and if it accumulates as the water evaporates, there's got to be something that's been left behind. So things that we need to consider and look at. So I'm going to now start getting into the encapsulator agent, what it is, how it works, and hopefully give some definition so that you understand that versus many of the other products that use that encapsulator or encapsulation terminology. F500 encapsulator agent conforms to the NFPA 18H section 7.7, the spherical micelle stability test. And through many third-party tests, it has been proven to stop thermal runaway and thermal propagation. It's also been shown to be able to reduce those toxic gases being released and encapsulating the corrosive, flammable, combustible electrolytes, as well as reducing the hazards and the toxins of the water runoff. So there's many benefits of using the encapsulator agent that we're going to bring when it starts getting into how this agent works and being able to deal with these types of fires. The ability of it to rapidly reduce heat, dropping those temperatures down, is what is needed to stop thermal runaway. Okay, until we can start cooling the adjacent cells, not just the ones that are burning. So when we talk about the ability of the encapsulator agent, it's going to deal with two things. Again, stopping the thermal runaway and the batteries that are failing, but it's also going to add that cooling effect so we can stop the thermal propagation where it's affecting other batteries. Okay, it prevents the reignition. And it's preventing it because even though you may have a little bit of a charge yet on those batteries and they may give a little bit of a spark with water, you're doing nothing to eliminate the flammable electrolytes. Okay, when you sit there and you talk about an encapsulator agent F500, and we'll see how it works in just a second when we talk about the 7.7 test, the encapsulator agent is able to encapsulate those flammable electrolytes, rendering them non-flammable, non-ignitable. So it helps eliminate that possibility for that reignition. The toxic gases that are being released, we've got reports, and you'll see those as I continue on, where we're able to encapsulate and greatly reduce the amount of HF gas being released. And it's not just the HF gas. You're going to be surprised how we have an effect on other things. And I'll show that in a report as we go through. And then all of the third-party testing that's been done showing the effectiveness of encapsulator agents on these. Okay, somewhere I got a video playing in the background. Sorry about that. Okay, this is to give you an idea of an encapsulator agent, how it works, and how it's different than many other products. And when they sit there and they talk about being able to encapsulate, our product is starts out with a molecule which has a polar head and a non-polar tail. Okay, the polar head loves water, wants everything to do to be in water. The non-polar tail fears water and wants to get away from the water. So when the concentrate is added into the water through educting, fixed systems, whatever, all those molecules go into the water and they instantly create these spherical micelles because those tails want to get out of the water. So the polar heads kind of protect the tails and they form those cocoons or those spherical micelles. When those droplets come out of the nozzle or the sprinkler head, whatever it might be, the molecules closest to the surface, they break apart, they spin out, and they now form a skin on the surface of each and every water droplet. And by doing so, it changes the characteristics of how that water droplet is able to cool and extinguish. The spherical micelles, yet internally in each and every water droplet, are looking to be able to encapsulate those toxins, those gases, those flammable or combustible vapors. And we'll see how that's going to play into this in just a minute. To give you an understanding of the size of those spherical micelles in the droplet, if that water droplet you see on the screen was the size of the Earth, those micelles inside of that would be about the size of a pea. Just to give you an idea of how many millions and millions of micelles, spherical micelles, are in each and every water droplet. They play an important function. So when we sit there and we start looking at others that make the claims, as I said, we've got some that say they're an encapsulator agent, and they form a shell, they form a crust, they work, they blanket, whatever it might be. They are not the same as an F500 encapsulator agent that meets that NFPA 18A standard, specifically the Section 77 spherical micelle stability test. So oftentimes we hear the word when I watch and I look on different sites, different pages referring to the product as snake oil. And again, that's kind of a thing that I find somewhat offensive because of the simple fact that all of the things that HCT talks about, the abilities of F500 encapsulator agents to be able to do, has reports to back it up. All the third-party testing. So it's not us just going out and making claims. It's based on test. It's based on results and performance of this product in those tests. So it's kind of offensive, and I hope to be able to, as I continue on with this misinformation, to be able to answer the questions and help you understand how this is so much different and dispel many of these I guess, false misinformation, things that are going on, not only with lithium-ion batteries, but with many other applications of the product. So as we go through and we start talking about, again, the F500 and what it is, as I said earlier, it is fluorine-free, it is non-corrosive, and it's biodegradable. It is a multi-class CULS NFPA compliant fire prevention, protection, and suppression agent. And what I like to point out here is it's a combustible and flammable vapor and liquid spill control agent. So when I'm doing my presentations with firefighter groups and things like that, I always ask the question of them, can you name me any other agent that you have in your toolbox that you currently use that will work on a combustible or flammable vapor? And I don't get very many responses. And again, when we sit there and we look at how those spherical micelles are formed in the animation, okay, we are encapsulating inside of those droplets those flammable vapors, and by doing so, we can prevent explosions and fires from occurring when you are dealing with these types of vapors, not just the liquids. So looking at the definition of what is, it's a water additive. That basic building block is that spherical micelle. I can't, stress it and say it enough. It's not forming a bubble. It's not forming a crust, or it's, a blanket or anything. We are chemically changing the makeup of a water droplet. So we're working on that chemical molecular level, okay, not on a mechanical level. The spherical micelles are able to encapsulate the carbon molecules, both polar and non-polar, or alcohols or hydrocarbons. And again, that vapor as well as liquid molecules. So when we sat there and started looking at being able to use this lithium agent on lithium-ion fire suppression, okay, when it's being used and testing has started, it's nothing that's new. The testing with the F500 suppression agent, the lithium-ion batteries, started back in 2008 with Bosch. So we are going to go through, as I continue on the presentation, we're going to get into a little of the chronological order in which all this testing has taken place. So it's not something that has just started. It's been taking place, and there's many prestigious groups and universities and institutes that have been testing it. So we're going to see just how this agent works. The reason why so many have standardized and are looking at the product is because when we're dealing with lithium-ion batteries, we're dealing with mixed materials. We're dealing with multiple classes of fires. We're dealing with plastics, or we're dealing with metals. We're dealing with synthetic. We're dealing with flammable or combustible liquids. So there's so many things and so many parts to a lithium-ion battery that need to be addressed when they're burning. And people have kind of standardized and are looked at F500 because it's able to deal with all of those different classes of agents or different classes of fires. So as we go through and we start to look at the flammable electrolytes that are, again, corrosive, they're toxic, the vapors while they're burning, we're learning about all the things that they're giving off that are hazardous, and not only to ourselves, but to the environment. So when we are looking at these fires and we start watching how violent these fires are, we need to also understand that the higher the charge on those batteries, the more violent they're going to be when they are on fire. So if you have a battery that's supposed to be at that 30% level when it's shipped, it gives off some pretty impressive fire, some explosions. But when you give it that extra charge, get it up to that 100%, the effects are much more violent, and the fires and the batteries are a lot more explosive and dangerous when they start to have things flying, as you've seen in some videos. And when you sit there and you get pictures off the internet where Tesla or other types of batteries have burned scooters, what do you usually see? A bunch of 18650s scattered all around the vehicle or the whatever it might be that has caught on fire. So these batteries can become projectiles when they burn. So we sit there, we start looking at the unique features of the encapsulator agent. Again, I've mentioned many of them that we're going to continue on and talk about, because some of the things that we'll see is we go through that burn back resistance. We're going to talk about some of the other issues, but specifically what we're going to get into is that 7-7 spherical micelle stability test. It's an important part of how this agent works on being able to stop the thermal runaway and stop and extinguish, I should say, the batteries that have that flammable electrolyte that you see jetting out of these batteries. So this is a real quick demonstration. It gives you a little bit of an idea of the 7-7. What we've done is we've poured some gasoline on the ground. Then we're going to sit there and grab just a 2.5 gallon, 6-liter extinguisher. We're going to spray a line through the center of it, and we're going to light one side of one side of that gasoline. As you can see, it's not going to cross over. Where we have the fire, you'll also see there's not a blanket. It's just a milky white discoloration to the water. Then we can go ahead and we can light the other half. And again, what we have already treated in between is not going to burn. So we're now going to come back. We'll go through and we will extinguish the fire, spray down the area, again, encapsulating the unburnt fuels that are still on the ground. Once we get done, we're going to grab that torch again. We're going to be able to walk through. As you can see, there's no blanket. So, you walking through it, we're not going to disturb. We're not going to create a hazard by walking through it because there's, again, no blanket to break. No fluorinated products. So environmentally, the cleanup of this right here is Mother Nature. Let it evaporate away, or if you're in a hurry, you can sit there and grab yourself a torch and you can evaporate it away with a torch. There is, again, no environmental issues. We are on the US EPA's National Contingency Plan as a surface washing agent. So there's no problems or environmental issues by allowing that just to evaporate away. Again, when we sit there and we look at that spherical micelle, that animation that I showed, how we put that skin on the surface of those water droplets, you look at that rapid heat reduction, that thermal conduit that we've created by doing that. We're driving the heat inside of that water droplet. And if you think back to the animation where we had all of those spherical micelles yet inside of the droplet, what happens is the tails on that water droplet, the surface of the water droplet, they act like a heat sink and they drive the heat internally into the water droplet. Those spherical micelles internal in each and every water droplet, though, they rapidly absorb that heat, but then slowly release it into the water that surrounds those spherical micelles. So through that process, the water that's inside never becomes or reaches 212 degrees or creates steam. So when you're using this product in water, we've eliminated the steam and how it works as far as being able to, again, cool and extinguish. So as I mentioned, how that thermal conduit works, here it is right here. It's the heat comes in, those tails on the outer surface, drive it in, those spherical micelles inside of the water droplet. They rapidly absorb that heat, slowly releasing it into the water again. And it's, instead of steam conversion like water is being used for, we're using what we call thermal conveyance. Okay, we're driving the heat inside, being able to rapidly cool, and again, eliminating that steam, the high hazard for burns. So when we sit there, we start looking. Here's a video from some testing that was done at the Port Authority in New Jersey. Ron Lowry, one of our other our Eastern area manager, was present at this one, and you can see from the bottom that thermal imaging just how quickly they're being able to extinguish this. And this is a 50-gallon compressed air system that's on the Port Authority's truck that they used, made up a solution in, and they're able to extinguish this fire. And you can see just from that video, and I'll back it up again because it is rather quickly. You see, a good flame going. You see the thermal imaging taking place. And the minute they start to flow this, you can see the color change in the vehicle because of the rapid cooling. And when we sit there and we start looking, and we do our trainings with many departments when we're dealing with these automobile fires, and we're doing some of the trainings with them, we're putting car fires out with 20 gallons of water, and sometimes possibly even less. But the amount of water needed to extinguish car fires, ordinary car fires, is greatly reduced by being able to absorb that heat and extinguish things. So as we go through, we're going to see just how now we're able to increase or improve the air quality. Because if I go back and I start showing you that video, you're going to see that the black smoke quickly turned white. And the question may become, what happened? What took place? Why did we have that change in color? And we'll see as I continue on through the presentation, what's taking place. And here's another good video that shows that from exact same thing happening. Here we have some tires that are burning. We've got that thick, heavy black smoke that's taking place. As we started using the encapsulator agent, you're going to see just how rapidly that black smoke is gone. I mean, here you have those tires are still burning. Where is the black smoke? Again, we're going to get into what's taking place and why that is happening. And to start with, I'm going to bring up the Clemson report, which has been with HCT for some time now. And it kind of answers that question. When we sit there and we look at it, it comes, for some reason, that wants to change on me. I apologize. We look at this inverted glass funnel, and for some reason, I can't get it to stay. Let me see something. So when we sit there and we look at this inverted glass funnel test that was done by the Clemson University, what they did is they were looking at three things, and they used toluene as their fuel source. The three things that they were looking for was the light transmission through the smoke to find out if there was a reduction or an increase in visibility. The other things that they were looking at was the accumulation of soot and then the toxicity of that soot. When they sat there and they did, the results were that the toxicity of the soot was decreased by 97%. Okay, the toxic smoke decreased by 98.6. The visibility increased by 68%. That's huge. Okay, I mean, right now, how many times do we hear about, firefighter deaths or things that are occurring because of lost visibility? Okay, well, we can see here, we can increase our visibility. When we sit there and look at that soot and the smoke, okay, we're going to get into some more discussion on that, because I've often heard and read in some of the different forums that I follow that, hey, we need a peer-to-peer review. This, is a lab test and so on and so forth. But there's really been no peer-to-peer reviews on the product. And it's true. And I'm going to show you one here in just a second. But just to give you an idea from this report, the carcinogens and the toxins that have been shown to be able to reduce from the Clemson report. Again, yes, it was a lab study. However, when we sit there and we start looking at this, it's talking about how this agent works and being able to interrupt that black smoke, what's taking place. And from this Clemson report, they're suggesting that it interrupts the vapor phase combustion, inhibiting the radicalescence into soot particles. So we're stopping that chemical bond where those soot particles are formed. We're interfering with that chemical chain reaction. And yes, this is from a lab and lab testing. So let's get in and talk about the peer-to-peer review. Here we have a report that was recently done by the Laval Fire Department up in Quebec, Canada. And they basically, because they had lost one of their brothers to cancer, wanted to find a solution. They wanted, and hopefully to reduce the chances for future firefighters on their department to be exposed to carcinogens and toxins, or reduce their exposure, and hopefully by doing so, reduce their chances for cancer. So what they did in this report, and again, these reports and things that we're going over in this presentation will be available to you. I believe Hernan will be sharing them with you. But in this report, they did 4 interior fires. They did 2 with plain water, and they did 2 with a 500 solution. After each of the fires, they replaced their hoods and they replaced the linings in the helmet. They bagged them up And for chain of custody, they gave him to a University of Ottawa representative who was on scene and was going to do the lab analysis on the hoods that they did in the fire. So again, they did 2 fires with plain water and 2 fires with the F500. And when we sit there, we start looking at the results that came from the testing that was done. Let's look at the decrease. Okay, when we sit there and we look at just plain water, like the naphthalene and all these other carcinogens and these toxins that firefighters are being exposed to, and then we sit there and we look over on the side where the F500 was used, we see the decrease. So 71, 83. Okay, there's none detectable, and so on and so forth. But we're seeing these rapid decreases, or these large decreases in what firefighters are being exposed to in everyday, ordinary structure fires. Okay, so here's your peer-to-peer testing that's been done. Okay, showing and basically backing up the Clemson report. The main thing about this report in the conclusion was, they decided, because of what they saw, the rapid ability to cool the structure, the increase in visibility, the reduction in the soot and the smoke that they were being exposed to. I mean, as firefighters, I'm sure not everybody on this presentation is a firefighter, but I mean, trying to get 30 people to agree on something is usually a pretty difficult thing to accomplish in many cases. After these firefighters did this testing, okay, the 30 of them that were involved all agreed that the Laval Fire Department should move forward in using encapsulator agent on all the fires to help prevent cancer in Laval firefighters. So gentlemen, here is your peer-to-peer review that I'm often hearing that needs to be done. So as I continue on, we're going to talk again a little bit more about that biodegradable, eco-friendly, non-corrosive. I can't stress enough, no PFOS and no PFOAs, even though there may be false reports out there that make the claims that there may be. Chances are, in most cases, it's testing that's been done after a fluorinated product has been used, and then after they aren't able to extinguish the fire, they use the encapsulator agent, and then they may do some lab testing to see what's there. And of course, because they've used the fluorinated ingredients beforehand, it's also then contaminated our product, so they're not getting the true results. We have subjected our product, the F500, to rigorous testing, excuse me. And we've got test reports from Giles Laboratories that at the different percentages, 1%, 3% testing that we've done, there is no detectable fluorinated ingredients of the 25 that are tested for. So we can proudly say that we are green and fluorine free. So when we look at that NFPA, the encapsulation 7.7, we are able to deal with those hydrocarbons, liquids and vapors. Again, I can't stress enough, because there is no other solution to deal with flammable or combustible vapors. Rendering fuels non-flammable, not ignitable. We've talked about that ability to rapidly reduce those temperatures, and that's one of the main things we're able to, or need to be able to do, to stop that thermal runaway and thermal propagation. Okay, the burn back resistance. We will hear and see when we get into this many times, some of our ordinary combustibles, but again, it's also one of the things that helps with that non-reignition of those lithium-ion batteries. The ability to reduce the soot and the smoke and the carcinogens, and reducing and improving ability, and again, eco-friendly. So now let's start getting into some of that third-party testing. Again, I've heard people, and I've seen in some of the sites where HCT's been paying for this, and we're the ones that are driving and making these reports and making these statements based upon tests that we paid for. And I again want to dispel that as a information. This is third-party testing that's been done, and we're going to sit there and we're going to start learning a little background on some of that. The testing has started since I mentioned earlier, back in 2008. So it's been extensive. With the third-party testing, we've got with NFPA, which is a global, and we're going to see how they sit there and they work on multiple codes. And I mentioned earlier how when that battery energy storage system failure occurred, injuring those firefighters, they instead of actually now getting into some testing, they did create a committee and created that 855 standard. But we're going to see how other areas around the world have sat there and addressed the issues with lithium-ion batteries. We're going to start and talk about the fact that many of the tests that have been done, and since this new standard was published here in January of 2022, we've even gotten some more reports that haven't been added to this. But if we go to NFPA 18A and Annex 4.3, it lists many of the third-party independent testing organizations that have done testing with F500 encapsulator agent on being able to extinguish batteries. And you'll see the Kiwa. We're going to go through and we'll talk about the Fraunhofer and the TL Clausel and some of the other reports and testing that's been done. So we're going to also get into how we're able to reduce the toxicity of the HF gas and some of the other gases. I had mentioned earlier, the CO, the CO2, the HF, the hydrogen, and things that are being released when these batteries burn. Well, we're going to sit there and see how in this testing, we have an effect on batteries in all of these difference. We're going to look at the NEN standards and how they work as far as being able to deal with the testing of extinguishers on being able to extinguish lithium-ion batteries. So when we look at that and the NTA 8133, this is a Dutch standard. F500, the encapsulator agent, has been and was tested up to a 600 watt-hour battery and very successfully able to extinguish it. So we sit there and we look at, where these size batteries are. Well, they're still somewhat small. You'll see them in scooters, you'll see them in laptops, in some household appliances, etc. So we're going to see how this testing was done as I continue on in the presentation, and we'll see that the extinguishing agent was able to extinguish those 600 amp hour or watt hour batteries, excuse me. And this was the test. As you'll see, we have a stand with a rack of batteries, and in order to be able to pass the test, you need to be able to stop that thermal propagation, that thermal runaway, before these batteries burn up. So when we sat there and we start looking at this, it was 3 tests were run. And when we sit there and we start looking at the batteries, you can see here that many of those batteries, especially those last 2 on the right, are still intact. It was able to stop that thermal runaway, that thermal propagation, and successfully halted the battery, extinguished it. And by doing so, now we have by Neuropene, which is a Johnson Controls subsidiary, extinguishers that are being sold in Europe with that European standard, and they are marketing F500. So I'm going to refer back to that snake oil again. Do you think a company as large as Johnson Controls or Neuropene over in Europe would be selling and marketing snake oil? Again, I want to hopefully, set aside some of the misinformation that's out there about the F500 encapsulator agent. So as we continue on, the testing, the DACRA. DACRA, again, was one of the first to start using it after Bosch, because Bosch had shared theirs. DACRA then went on to sit there and do some testing on it on some more vehicles, and they shared their findings with the Automotive Society of Engineers in Detroit. So again, it has been shared that these agents, encapsulator agents, do work. I mentioned Johnson Controls earlier. Kiwa Labs is some third-party testing again that was done. Kiwa is another large testing group and organization, and they did this test with regards to lithium-ion batteries, and it was for and on behalf of HCT Europe and Johnson Controls. They were looking for independent third-party testing for a solution for lithium-ion batteries for a customer. The customer didn't want a Johnson Controls solution. They wanted third-party testing. So Johnson Controls tested all of the products they made in the United States and in Europe against F500. And it was like 3 or 4 days of testing to get all this testing done. And as you can see on the left-hand side, they're using powders. I want to mention over here on the right-hand side, you'll see how quickly he's able to extinguish that battery with the encapsulator agent. He's not using a constant spray, just short little, couple second bursts with the powders. Okay, the powders are absolutely useless. You'd have to basically be able to build up enough powder so you can cover the entire battery. The foams, again, didn't work. So when we sit there, we start looking at the report from Johnson Controls from this testing, it shows powders were poor. Their recommendation, don't apply. We look at foams, they gave it a moderate to poor, but the recommendation is no, don't use. But with the testing that was done with the encapsulator agent, it's sufficient, all 3 tests, and is recommended for use when we sit there and we start looking at encapsulator technology. When we sit there, we start looking and continuing on, okay, again, we sit there and we start, looking at a brochure that is available with Johnson Controls, again, through their subsidiary with Johnson Controls and Neuropene, and it's showing the use. And I know in many cases we find people in the marine fields that are looking for solutions because of cars being transported on ferries or ships being sent from across the globe to different areas. And again, you're seeing here from, again, this isn't HCT's, this is Johnson Controls literature. You're seeing, how they're recommending the agent to be used for extinguishing these fires. We sit there and we go into this other one, and you're going to again see how they've got a brochure that then also covers, executive summary. And again, how they are marketing as the solution for lithium-ion batteries, F500 encapsulator technology. We get into and we start looking at the test in this, the conclusions of this third-party testing. And when we sit there and we start looking at it, and I'm really not done. I'm going to get into more. This is just with the Johnson Controls, but they're showing that this has been able to deal with these batteries, and we're going to find out how it's better than the foams and better than the powders because they were unable to extinguish. They weren't able to stop that thermal runaway. They weren't able to get rid of that explosive behavior of the batteries. Yet the F500 was able to quickly extinguish these fires, reducing the danger, reducing the hazards that they present. And as you can see from this one, it's talking about in the test, it was able to drop the temperatures down to that 150 degrees C in a short period, which was regarded to be the temperature when a battery reaches that you can no longer have to worry about the thermal runaway. We start into now the TL Clausel University and some of the testing that was done with them. That because when we looked at the first testing, you saw the gentleman was not wearing an SCBA. After that testing, he ended up spending some time in the hospital, having to go through some detoxing because of his exposure to the HF gas. So because of that, now testing went indoors and they were monitoring that gas and those hazards that were coming off of those batteries. And as they sat there and they did, They found that when they started using the encapsulator agent, okay, when nothing was used, but let's say the plain water or there's no extinguishment, the parts per million were somewhere in the area of 227 to 2,656 parts per million that were being released. Yet when they started using encapsulator agent to extinguish these batteries, the highest readings of HF gas that they got was 37.45 parts per million. That's a great reduction from 2656, the highest without, down to as low as 37.45. I mean, let's look at the AEG guidelines. I mean, we're at 37 that we knocked it down to. Well, hell, 34 parts per million gives you a 30-minute acute exposure. So the amount of HF gas that is being encapsulated and reduced is significant. It's huge. We started looking at another agency that did testing, the Fraunhofer Institute. Again, another research organization in Germany. Many different areas. It's a respected college, university, and they did testing. Now, in this particular test, this is a battery that's in a Connex box, and they've got sprinkler heads set up in a Connex box. And we're going to see that they're overcharging this battery, and it's going to go into ignition here in just a second. Because they've got sprinkler heads set up inside of this Connex box, there's not going to be anything that's automatically or manually or a human intervention as far as they're using the temperature bulbs that are in the sprinkler heads to activate the system. So you're going to see that this battery is able to go into its free burn. It's going to have the thermal runaway and thermal propagation taking place. You're going to see multiple batteries that are going to become affected as this continues to burn. You're going to see that off gassing. As the video, you'll sit there and you see it's more difficult to see some of the sparks and some of the materials that are flying out of the batteries and around the container. But you'll know and you'll see when the extinguishing agent is applied, because in an instant, while it's burning, you can see it. It's highly visible because you can see the flames. In a second here, you're going to see, and you'll have a better understanding of just how quickly the encapsulator agent is able to work on being able to extinguish a lithium-ion battery. And it should be happening here in just a second. It's getting plenty of free burn time, and there it is. System activated. That battery fire is out. It's been extinguished that quickly. We get into another test report that was done, and again, some of the things that were done. It's showing these lithium-ion batteries. Thermal imaging is being involved with this one as well. We've got some temperature probes. We'll see how quickly those temperatures go up. The spray nozzle that was above the battery got melted. It became part. So actually what they have is just a tube that's blowing straight down on top of it. It's not a dispersed. But you'll see again just how quickly from the top left, the temperatures, how quickly the temperatures dropped. You can see from the thermal imaging also just how quickly those temperatures are dropping and continue to drop as the agent's being applied. So when we look at that Connex box, that other test, the previous test, you'll see, some of the testing, some of the instrumentation that was involved and being able to, but again, all of these different groups were part of the testing. HCT Europe, okay, the Brandt Schultz Services, Johnson Controls, Fraunhofer, TU, Costal, and Neuropine. So many prestigious and many great groups were involved in this testing. Going and learning about how well and how efficient encapsulator technology works on being able to extinguish these batteries. Now, at the beginning of the presentation, we saw the video where we had the firefighters from Surprise, Arizona, the battery energy storage system that were blown. The one, I believe, was 30 feet. The other was 70 feet through a cyclone fence. Luckily, they survived. Okay, and again, I mentioned that from that incident, we here decided that there was a need to do something, and we created the 855 committee. Unfortunately, when we sit there and we start looking around the world in Beijing, a similar incident occurred. Firefighters weren't quite as lucky. Some were killed in the incident that happened there. So in Beijing, they sat there, the Chinese government, they decided they were going to do some testing. So they started out with the test, testing all the different agents. They tested powders and gels and foams and all the different things. And when the testing was done, they found two solutions that could possibly work. Well, one was water mist, which is highly talked about, and the other was F500. Here's a copy of the full report. I'm going to go ahead. I'm going to just briefly show this to you. Again, will be included with the information that you get at the end of this when Hernan shares with you. This report came to us quite by accident. It was Google search, thanks to Hernan. And it talks about, again, the F500 being able to suppress a lithium iron phosphate battery, the fire and the cooling. And again, this is the full report. I'm going to talk about it just a little bit. I have a couple slides I'll get into, but when you get this and shared with you, please take the time to go over it, because just like here in the United States, as you can see right here from this graph, okay, the number of fires that they're experiencing in China or anywhere in the world is growing as the number of lithium batteries being used within the country or around the world are increasing in their use. That's a very good report. Please, you'll see a couple of things that I want to talk about. When we get into the synopsis and what they were doing, they were using the 3% solution, and they were comparing it with a water mist system. And when we sat there and we talked about the ability of the F500 to reduce the HF gas, well, this report is going to talk about more than just the HF gas. It's going to talk about the reduction in toxicity of the water runoff. It's going to have some things in there about hydrogen gas, the explosive gas that we also have to worry about. And in the report, when they sat there and started looking at this breakdown of the toxic gases that are being used, you'll see right here, it's showing you just how much of all of the different gases or what's in the gases and roughly the percentages. When we looked at the off-gassing, they did a comparison between that water mist system on hydrogen gas that was being emitted. When they had the batteries burning, they were getting 476 parts per million. When they used water mist to extinguish, they were able to have a great reduction. They dropped that down to 270 parts per million when they used the water mist. But when they used the encapsulator agent F500, they dropped the hydrogen down to 14 parts per million. Huge reduction. The explosive gas is right there that blew up the container in Surprise, Arizona, that helped injured those firefighters. Here we are having a huge effect on reducing the amount of hydrogen gas. And it's not just hydrogen gas with lithium-ion batteries. I mean, let's look at all the different areas where we may have concerns with hydrogen gas. Okay, here now you're being shown a solution to be able to deal with by adding F500 into your fixed system or whatever it might be that protects that facility. We have a solution to be able to reduce the amount of hydrogen gas that might be released no matter what application. It's not just with lithium-ion batteries. Some of the other things that we see, it shows how, again, we're able to have an effect on the fuels, okay? The hydrogen as well as the flammable electrolytes, the interruption of the free radicals, that black soot, the carcinogens, that smoke, okay? The smoothing effect, reducing the concentration to oxidizing, the cooling effect. But all of those things are covered in this report. So, I mean, please, when you get that, take the time to review it and go over it. To try to do it in this presentation, it'd almost be a presentation by itself. A lot of great information that comes from that. But those are the key issues. Being able to reduce the H2, the hydrogen gas, the hydrogen HF gas, the hydrofluoric acid, and then now let's talk about that water, because people are always asking and always talking about the hazardous water runoff that's being caused when we use plain water. And I know I see some people saying that it's diluted so much it's really not causing any issues, but that dilution, when the water evaporates away and you don't have that in diluted anymore, because the water's evaporated away. When the water evaporated, did it take the hydrofluoric acids with it? So there's some questions that maybe need to be asked. What happens as the water evaporates? Let's get into the TU Clausel report and see what some of the things that we've learned with that. And again, this is another great report. They did some testing with lithium-ion batteries, and in their testing, they had 50 liters of plain water, and it was unable to extinguish the lithium-ion battery fires that they were testing. So they then went to a 2% solution of F500. And I know previously we talked about 3, but in this particular instance, they only used a 2% solution. And when they did, they again had a fire, and they used a short 5-second duration burst of the encapsulator agent. After the first, they knocked the flames down, but there was some reignition. They gave the second burst. They were able to totally extinguish the fire. After that second burst, there was no reignition. Then they gave 2 additional 5-second blasts just to continually cool the battery down. So they went from 50 liters not being able to extinguish to about 4.5 liters where they were able to extinguish the battery. So in that, then they also looked at the water runoff, the elements and things like that. There's some other testing reports that I'm going to go into that really talk about that wastewater. But let's think about that. If we're sitting there and we're using that much less water to extinguish these batteries, we're not going to have that water runoff. And if we're able to have an effect on being able to reduce the toxicity of that water runoff, that's another plus. So I'm going to now get into an actual incident that occurred, and it was covered in this Brand Schultz magazine. It deals with a high voltage lithium-ion battery fire. And the reason why I'm going to talk about this, I'm going to spend a little bit more time with this because there's a lot of good information in here. Because it comes into, and one of the first things it talks about is the fire of a high voltage battery on a test stand. Okay, now we've talked about that extinguisher, that 600 watt hour extinguisher. Well, here now we're getting into an actual battery that would go in a vehicle. It was on a test stand in a climate chamber. In the climate chamber, they could adjust the temperatures. Then it had a wide range of temperatures from and so on. But when we sit there, we start looking at this, and this talks about the response. It talks about the hazard, the fire that occurred inside of this test chamber. It talks about the battery once it went off. Some of those 18650s, they kind of flew up inside of the test chamber, embedding themselves and burning and melting themselves into the ceiling and other areas of that test chamber. And let's see if I can't blow this up just a little bit. But you see here, it shows the temperature range for this test chamber was from -40 to plus 120 degrees C. So it had quite a temperature range. What the temperature was when this particular fire happened, I'm not sure. But it talks about the test rooms, how they're built up, and it's a rather large facility that can do multiple tests on multiple batteries on a single day. Inside, they did have a chamber that they could use to basically suppress and keep the solution if a battery were to fail and they needed to activate the fire suppression system. It would contain the runoff within a tank that housed the battery where they were testing it. So in here, it talks about they had a battery fail. It was caused by a bearing, overheated bearing. That was part of the testing. So anyway, as they went through the response with the fire department arriving, came along. The battery was extinguished by the system, the fixed system again, like we saw with the Connex box. The water was contained. We had some leaking. They went in and they ended up having another container that they could put the battery into. And in the process of taking it out of the test chamber and then moving it from the test chamber, and they moved it because the container that was in the lab developed a leak. So they were looking to move the battery into the box that you see outside on the top of the truck, using the high-low, the forklift. And through the process of moving the battery, it's also noted in the report that there was no reignition of the battery while they were moving it. But one of the key features that I wanted to get into, because I see again in many cases and in many threads and many Facebook posts and things that I follow, that people are making the assumption that the F500 has to get onto the battery in order to be able to work. And in this report, it talks about, and I mean, while this is really one that talked about the toxicity of the water and the pH and being able to neutralize it to a pH of 7.2, okay, and instead of having to go to a industrial wastewater treatment plant, they were now able to treat it with just a municipal wastewater treatment facility. So the toxicity was greatly reduced. But one of the key things that really comes out of this is right here that I've highlighted. According to the head of operations, the use of F500 resulted in rapid cooling and thus prevented the spread of fire, even though the extinguishing agent only reached the outside of the intact battery housing and thus not the battery cells themselves. Okay, now this comes to us from a report from an actual incident where a battery caught fire in a test chamber. Okay, the F500 was not put directly on the cells, it was able to extinguish coming in contact with outside housing of the battery. So again, I see a lot of people making comments, and I'm hoping, again, we can clarify and stop a lot of the misinformation and get more people on board with exactly how this is able to work. So even though they had this in a test chamber, and again, we talk about that water analysis from the Brand-Schultz magazine, bringing that water to a pH of 7.2, and reducing the toxicity and the hazards because it's been encapsulated. Okay, so again, it talked about that being able to extinguish the fire from the housing. So in a quick summary, I mean, I've talked a lot about the NFPA 18A, especially the 7.7 encapsulation abilities, that ability of the agent to rapidly reduce those temperatures without creating steam, how we are able to significantly reduce the toxins and the carcinogens. And when we sit there and we look at the foams, we talked about how they work on that mechanical level, unlike the encapsulator agent that's working on that chemical molecular level. Foams are poor heat reduction. They don't work on three-dimensional fires, and they don't reduce the toxins. Your inerting gases, mechanical, poor heat reduction, they basically suffocate the fire. They stop the visible flames, but they do nothing as far as cooling the battery. So in that situation, you're just creating what happened in Surprise, Arizona. You're creating a ticking time bomb. You sit there and you give it the right amount of air, you get that air fuel mixture just right, you have those explosions. The water, again, working on mechanical level, minimal heat reduction. That's why we're using copious amounts. That's why we need 30, 40,000 gallons of water. Or if it's in a battery energy storage system, we're using millions of gallons of water. Okay, again, let's look at how we can reduce the environmental impact, especially when we start looking going out west where people are experiencing drought conditions. Do we really have that much water that we can use on one battery energy storage or one car? When we have a solution, protecting. When we look at some of the industry leaders, we talked about the Johnson Controls, TL Clausel, here's, some others that are using the product in one way or another to protect their facilities where they manufacture, where they charge, where they use, or where they're being used. Let's look at battery energy storage system. Again, I'm 855. Well, as in the process, we been able to educate and show people the test reports and how effective the encapsulator agent is in being able to extinguish these fires. And we do have some battery energy storage systems that are protected by encapsulator agent. Okay, we sit there and we start looking at the detection and being able to integrate the detection in with it. The ability of the encapsulator agent to cool, extinguish, reduce those toxins, the soot, the water runoff, with the use of our diamond doser water-driven proportioners and you know, the encapsulator protection. When we talk about the VEEP, the vapor encapsulation explosion protection, you know, that vapor that I kept talking about, you know, does the fire service have a solution for flammable combustible vapors to prevent an explosion from fire? Well, hey, guess what? It's covered under NFPA 18A, under the VEEP. So there is a solution for those. So as an example, when we sit there and we start looking at it, you saw how effective we are if we can get onto the surface of the battery. So the solution is, and what we've done with those battery energy storage systems is we have a system, get into the rack, put a space, you know, something, a nozzle above the height of each top of each battery. And guess what? With detection equipment and things like that, we can sit there and we can cool these batteries down. We can prevent these from being catastrophic incidences, you know, that affect and cause neighborhoods to be evacuated. Okay, so it's a huge thing. And while many people sit there and start, you know, saying, you know, and talking about those, the lithium-ion batteries that are in vehicles, and you know, other pieces of equipment or electronics and things like that, and they have many concerns. I want to quickly show you one that concerns me. And this is what we're going to be seeing in the very near future as these lithium-ion batteries and their use continues to grow. When you have that Tesla that makes it to the scrapyard, or you have some of these other batteries that make it to the scrapyard, there's going to be somebody that's going to go off and they're going to pick them up. And they're going to try to make their own battery. That's what scares me. Okay, because that's what you're going to start seeing in race cars. That's what you're going to start seeing in other applications, because maybe they don't have the standards and the things that need to be put in place to really do the protection. So with that, I am going to go ahead and open it up. Again, I'm going to go to the very last slide here. So that if you do have any questions, we're going to have our contact information. You can call or email. Feel free, more than happy. If your group, your organization would like to have some more in-depth or set something up where we can do a presentation for your group, your organization, fire departments. I know you're out there, you're looking for solutions, you're looking for answers to deal with these types of fires. And again, as I've said, while the manufacturers won't endorse a product, that is a solution. HCT will be more than happy to work with you, come and do some presentations, do some training with departments so that we can get you on board with a proven agent that can work in these types of fires. So I want to thank everybody for attending today's webinar. It's been my pleasure. Again, I'm going to end with saying, you know, if this is something that you would like to pursue further as far as a presentation for your group, your fire department, your organization, please contact us. We'd be more than happy to do more with you. But by all means, you don't go away with questions unanswered. Contact us. We'll be more than happy to share reports, answer your questions, and show how we can be a benefit. With that, thank you. And have a good evening, good morning, whatever it might be in your time zone. Appreciate everybody for coming.